Hello, welcome to Mahr's June product of the month, the Digimar 816 CL. I'm George Schutz, your presenter, Director of Precision Gauges out of Providence, Rhode Island. And as we go through today's webinar, if you have any questions, use the chat feature and I will respond to your question after the webinar by email. Thank you again for attending. Today we're going to learn about the 816 CL digital height gauge, talk about what it is, some of its features, review the technical data, talk about some of the accessories and the application types of things it can do, why you might need it, and then we'll review Mahrlights and the product of the month promotion. So what is a height gauge? Well, the need for a height gauge has been around since the principles of layout work became fundamental in today's machine shops. Now, the first step in manufacturing process is to lay out a piece by transferring a design or pattern to that workpiece. And as with most inspections, the surface plate provides a reference plane from which the part or the height is measured from. So height gauges are used to set the mark on certain height on a workpiece, or they can be used to transfer a measurement of the part that's been machined. Now, height gauges have changed a lot over the years. We went from a simple scribing type of height gauge that's been around for more than 100 years or so. Then we've gone to taking basically a vernier caliper, turning it on end, and using that as a height gauge called a classic vernier height gauge. And that one's been around for 100 years or so. And it's still being used by those true machinists out there. Then to make things a little bit easier, a circular height gauge, which uses a dial indicator to set the height, came on board. And that's been around for maybe 80 to 90 years or so. And people still use that type of height gauge because it has a very easy to read, basically a dial indicator to help set the height. The most recent addition is the digital height gauge, which allows for a direct reading of the height, or even setting zero locations at various planes other than the reference surface plate. And now the latest generation of height gauges are microprocessor based, they're motorized, and aid the user in making surface plate measurements. And more than just heights, they can do a lot more measurements than a pure linear height measurement. And Mahr offers three classes of height gauge. Our 814 SR is our manual scribing, measuring height gauge, and we did feature that as a product of the month a few months ago. Then we have the 816 CL, which is a one-dimensional motorized height gauge. Comes in two versions of 14 and 24 inches. It's motorized and has an air float base. And it offers full one-dimensional 1D icon-driven functions for lengths, IDs and ODs, widths, dynamics, auto zero, and auto probe calibration. And then on the higher end is our 817 CLM, which is a 1T or 2D motorized height gauge in three versions up to 48 inches. Again, it's motorized drive and air float base. It offers 1D measurements for length, IDs and ODs, dynamics, auto zero, probe calibration, etc. But it also is a 2D function for doing things like squareness, bolt circle pattern, plus it has some statistical features. And it comes with three measuring modes to make it just a little bit easier to use. But today we're going to concentrate on the 816 CL, which is our product of the month, and we'll talk about some more of the features of the 816 CL. So what is it? The 816 CL is a high-performance, cost-effective, and easy-to-use digital height gauge for general-purpose surface plate layout and measurement applications. It's designed to be used on a surface plate near the point of manufacture. So it doesn't have to be relegated to the quality control room or the incoming inspection area. It can be used right near the point of manufacture. And with its digital electronics, it allows for semi-automated measuring and transferring of the data for recording. So it's a pretty full-feature height gauge. And most of the applications for 1D measurement are 1D length measuring, using the surface plate as a reference to measure lengths from that plane. So, in this case here, we can measure, the lengths like F1, F2, F3, F4, and we can also measure from the bottom for F5 or the height of F6, and even get the width of F6 to F5, and even find its center line location. And you can zero either on the reference surface, or if you wanted to measure from just F6 to F5, you could do that by zeroing on F6. So there's lots of different applications for the 816. But the primary main applications are 1D measurements, and if you're looking at the display here, you can see that there's icons for doing certain things. So there's icons for doing a probe measuring for doing diameter, for measuring on a top surface, or measuring from the bottom up on a surface, or measuring within the slot. So these are the 4 main applications. They're the most prevalent, and thus there's an icon and a key button to make those measurements. But there are some function things or some secondary applications which are easy to use, and by pressing the function key located down here, a series of soft keys will come up, allowing for different types of 1D measurements. And that's for measuring underneath or above a radius, like a shaft or something, measuring in the hole from the bottom or the top to get the location of that hole. So there are some other functions that are available through these soft keys. And even more secondary applications are doing outside for doing the diameter of a shaft, to measuring thickness within and getting a center line of a groove, for example. Or you can do some dynamic measurements and check flatness or so from above or from below, where you can even stop the measurement while you're doing that to move it over to another spot, for example, to go over a hole or some other feature in the part, and continue that min minus max dimension to get the dynamic flatness of a part. So soft keys are a way of expanding the capabilities of the 816, but still making it easy for the user to use. Less keys, less confusion for the operator. And that's why a lot of people like the 816, is because it's primarily their job is to measure some lengths. So we make it as simple as possible for the operator to use. So besides the simplicity operation of the 816, it has some other important features. The first one is the motorized measuring head. So this simplifies the task and minimizes the influence of the operator. So with any type of measuring system, anytime that the operator touches the gauge or becomes part of the measuring, he has the ability to influence, or he or she has that ability to influence the reading. So by making the system motorized, the operator just presses the key to make a down measurement, for example. It eliminates that influence of the operator and improves the repeatability of the whole measuring system. So now the measuring results are precise, reproducible, and reliable. We say it's very easy to the operator. So I pointed out the single key operation. They're very clearly stylized on the control panel, and most of the functions can be executed with the touch of a single key. If you have a number of parts that you're going to be measuring, you have a production run and you have a series of parts, you can teach the 816 and create a program that enables quick and reliable measurement on those production components. So once you go through a measuring routine once, you can save that measuring routine and pull it up and do it again. So it's very easy to do. And what will happen is as you begin the measuring routine and move from one length to another, the gauge will move to the next position, and you tell when it's ready to go, it'll go down and do that automatically. There's no moving of the slide. The 816 will do it automatically for you. Now, some of the other features of the 816 is the fact that it comes in two measuring sizes, a 14 or a 350 millimeter version, or a 24 and 600 millimeter version. They're both switchable from inch to metric with a 1/10 resolution or 1 micron resolution, and they both have the same error limit of 2.8 microns plus the length that you're measuring. So you have to remember that, you're really improving the measuring process if you're only measuring from over a short span. So that short span can be anywhere within its full measuring range, and you have the 2.8 micron accuracy. So both systems employ a sturdy, heavy-duty base, ground surfaces. It's easy to move with the integrated handle. All the contact surfaces are hardened and lapped, which produce a smooth and even movement of the slide. And an air-bearing system is built into the system for light and easy positioning of the height stand to large parts. So, you can, if you have small parts, you can bring them to the gauge, or if you have large parts, it's very easy with the air-bearing system to bring the gauge to the part and locate it easily. So how do you get the most from the height gauge, the 816, for example, and so forth? So let's take a look at the steps that are used to make a proper measurement. Well, the first thing you want to do is, with any height gauge, is set a reference point. So when the 816 is turned on, it's powered up, it's automatically going to set the reference point on the surface plate. So as you power it on, you'll see the slide is going to move up a little bit to find its internal reference. Then it's going to come down and touch off on the surface, and the 0 point is set. So it's going to, you turn the unit on, it's going to go up, it's going to come down, touch the surface, and you'll get your 0 point set automatically for you. But anytime you're going to use the height gauge, it's always good to, just to regularly, during the course of the day, reset the reference point. And that'll take out any temperature variations. As you move the surface, the height gauge around on the surface plate has some flatness errors. And you want to be able to work, if you're going to work locally, to take advantage of that and reset your 0 point to make sure that you have the least variation. And during the day, you want to wipe off the surface plate just to take off any dust or contamination that might have fallen on the surface plate during the day. You can wipe off the surface plate, reset your 0, and that'll improve the performance of the measuring system. So you press the the zero function or 0 point key, and then you're going to press the function for doing your zero. The probe is going to come down automatically and set the reference, and now your 0 point is set. So you should do that a number of times during the day to improve the performance of the measuring system. The other thing that you want to do is ensure that you have the proper probe diameter as part of the measurement. Now, since you're apt to make measurements from the reference system to the top of the part, and also from the reference system to maybe underneath a ledge or something, it's important to know what the measuring diameter of the contact probe is. And the 816 has an automated feature for doing this. So basically, on the keypad, there's one button here that helps you calculate the probe diameter. So you press the probe diameter key, and then you select what type of reference calibration system you have, whether it's an inside ledge one or an outside ledge one. You choose the one you want, and then you press that one, and it'll automatically move to the bottom of the probe or the ledge down to the bottom, to the top of the ledge, and it's going to calculate for you the probe diameter. So it's a very easy to use automated system for calculating the probe diameter. And again, you should probably do that a couple of times a day just to ensure that it's a clean probe and you're ready to make good measurements. It's a way of helping, again, improve improve steps to get the proper measurement. And making a surface plate measurement for length with the 816 is easy as 1, 2, 3. So basically all you have to do is manually position the probe over the surface that you're going to measure, press the down contact from above key, and then the 816 will, with using its motorized drive, will move down and touch off on the surface, displaying your results. So the results are displayed in a easy to read, large lit display, easy for the operator to make his measurements, simply using the one key. So you position over the part, press the down measurement key, and the 816 will take over and make that measurement for you. It's very simple to measure bore diameters also on your part. So here's again, we're going to just add one more step to the function. So we're going to move the 816 into the bore that we want to measure. We're going to press the bore diameter key. The 816 motorized drive is going to move up, and now you manually slide the part, or you can move the 816 in the part, sweeping the bore for its highest point. Once the 816 captures that highest point, it's going to move down to the bottom of the probe, and again you can sweep either the part or the 816 across the bore to find the largest or lowest point on the diameter. Once that's captured, then the 816 is going to show you what that diameter is, and it's also going to show you the location of that diameter from the surface plate. So it's very easy to make a bore diameter. The 816 has the pre-built-in measuring routine to do that. And whether you're measuring contacting from above or below, all these features are all automated, they're pre-programmed, and are available for the operator to easily make a measurement. But again, contacting from above, measuring the bore diameter are the ones that are most common and that you're going to use. But whether it be a bore or a shaft diameter, there's functions for us to do that. Just like the min-max function, it's a simple key operation to get us to look for a flatness measurement, for example. So all these functions, they're all available either directly or through the function key, and they all guide the operator through making that specific measurement that you want to make. Now, data functions within the 816, we talked about part programs. You simply measure your part, and through the teach-in function, you're going to take that routine that you just did, you can save it, and then use it again in the future. And as you're making your measurements, you can use the data collection feature. So, with the data output function, you can collect data wirelessly through our add-on modules. You can use the USB port or to use RS-232. So that's the unique thing about all the Mahr products, is that there's one output, and the cable that you choose selects which format you want. So you can use from that one connector that's on the back of the product, you can use a wireless adapter to our eStick. You can use the cable for an RS2 for a USB output, or you can use the RS-232 cable to get that output format. And any one of those outputs can be collected through MarCom. And MarCom is our free software package that allows us to collect data from many of our products, whether it be wirelessly, the wireless gauges we have, through the add-on wireless technology, or using cable technology through the USB port directly into a computer that's running our free MarCom software. And with that, you can collect data, send it to an Excel program, through a SPC software routine, to any Windows software, or we have the means to go into a third-party software if required. And we're always updating MarCom. We're up to a version 5.3.1 now, where we're doing things that make the data collection more valuable to the user. And one of the most important ones that I think is important is that we can assign a gauge number and a part number to the device making the measurement. So, now that we can do that, we can tie the measurement data to the gauge with the time, date, and collect all that information as part of the standard measuring routine. So we can select to collect the additional data, the description, the serial number of the gauge, the part number of the gauge, the date and the time, and that can all become part of our measuring routine. Another additional feature that we've added was the ability to reset or retract that last data measurement. So if you collected data, it's not good, you can use to reset the last data transfer and erase that value. So we have the 816. We've talked about how easy it is to make the measurements. We've talked about the ability to collect data through MarCom and at Mahr connect to cables and so forth. And as far as technical data, we mentioned that there's two versions, a 0 to 14-inch version and a 0 to 24-inch version. We've talked about the resolution. We've talked about the accuracy or the error limit of the system. There are repeatability specs for making measurements on planes and for making measurement in bores. There's a perpendicularity error. We can adjust the measuring force if we like. And we have the standard operating temperature ranges that we would expect for the 816. And of course, the data interfaces are standard and built into the product, selectable with wireless or the cable that we're going to use. There's lots of accessories available for the 816 to make those measurement applications, just expand them a little bit. And we offer kits with different probe combinations in them. We offer a kit, a universal small bore set. If you're measuring very small parts, you need to get into bores or into small grooves and so forth, we offer a kit to do that. We have some depth probe carriers, so if you need to get over and down into a groove or down into a bore, we can offer the tips to do that. And of course, there are the accessories for the data connection cables, the wireless transmitter and e-stick and receivers. All those things are just standard accessories available by purchasing the part number. So we have a pretty powerful 816 CL, but with and height gauge is just as good as the environment and the people using it. So there are some tips that you can think about for making a measurement. So as with any measurement, the quality of the result depends on the instrument and the operator who's handling. So many gauges are designed to make this as simple as possible, especially with the 816. A snap gauge, for example, has a reference anvil, a frame, and a measuring instrument built in. The same is true with a bench stand. So to obtain a good measurement, all the operator really has to do is apply the gauge to the part. And electronic height gauges are not as self-contained as other gauges. They have the precision scale, but there's really no integral reference. That's the most critical part. So electronic height gauges are used on the granite surface plate. The plate provides that reference for both the height gauge and the part. So the quality of the base plate directly influences the measurement result. Thus, it's important to keep that plate free of chips and dust and dirt. You would think that with a snap gauge, it's the same concept. We want to keep the anvil clean. In the height gauge, we want to keep the reference surface clean, or the surface plate. Most height gauges are direct reading instruments and generally operate in ranges from 14, and there are height gauges that go up to 48, but the 816 goes up to 24. So they're very, when you're talking about measuring over that length, they can be very susceptible to variations in temperature. Body heat from the operator is a source of heat in making a measurement. Most temperature quality control rooms are set to 68 degrees, and all those elements from the base plate to the workpiece to an air conditioner, they all can cause local heat expansion and induce measurement errors. Therefore, it's considered to use these guidelines. Avoid touching the test piece with your bare hands directly before making the measurement. It's always wise to use gloves. Never touch the other elements of the measuring circuit. Don't try and handle the 816 by the column itself. Use the knobs and the handles that are on the gauge to position it. So that's what you want to do. You want to touch the height gauge at the points provided for the purpose. The handles, the air-bearing movement switches, that's what you want to move the gauge with. And that will not transfer the heat to that measuring circuit. Again, avoid drafts, avoid the surface plate going into direct contact of the instrument, of the workpiece or the base plate. Do not set the measuring station in proximity to radiators or to the path of airflow ducts. Do not check test pieces that were transferred through very hot or very cold rooms shortly before making the measurement. And, like I said before, double check the zero reference for the measuring system. This is the basis for all your measurements. So again, re-zero and get a good recent 0 point and use that for your best measurements. So why is the 816 the choice for my surface plate layout needs? Well, it's easy to use. You get good performance out of it. You can use it in the machine as part of the machining operation area or in an inspection room. With its motorized slide, you're again reducing the operator influence and are apt to get more repeatable readings. The data output capabilities provide transparent data storage for the operator. And with its promo pricing, the 816 makes it a high value height gauge compared to some of the other choices that you may be able to find in the market. So the 816, Digimar 816 CL is our product of the month. It's also promoted through our Mahrlights promotional flyer, which I believe has been expanded or extended for the next couple of weeks. So, but right now, if you order it through June's special offer, you're going to get the free Mahr mug in addition to the promotional prices of the 816. And both units, both the 14-inch version or the 24-inch version are at promotional prices, available again with the Mahr mug as part of the deal. So today we've discussed what the 816 CL is, its features. We talked about the accessories and the applications for 1D measurement that it can do. We talked about why it's the right choice to be used at the point of manufacture. It's high performance. It's made for being used at the point of manufacture. It has the capabilities to make simple, easy measurements for people who may not be quality control technicians, but with its simple one key operation, anybody can make accurate and easy and fast measurements at the point of manufacture. And because the 816 is in the Mahrlights and it's this month's product of the month, it's a super value. And why Mahr? Well, Mahr has a wide range of products for industrial metrology. We have the application competence to support you. We have a great wireless hand tool portfolio that may help you reach Industry 4.0. They're all easy to use, transparent for the operator, and a great value. With our promotional prices and high quality, we can give you some of the best values for your measurement needs. And then after this webinar is over, we're going to provide you with a link to the recording of this webinar and again a PDF of the product of the month data sheet. So if you had any questions, make sure that you type them in and I will respond to them after the webinar. So thank you for your attention. You can contact me anytime at george.schutz@mahr.com. Give me a call in the office and we'll be glad to take care of any questions or application support that you need. So again, thank you for your attention today and attending this webinar. It's been a pleasure providing this information for you.